Thank you. Thank you. So hi everyone. My name is Alon. I'm from Tel Aviv in Israel. Um, and at Aporia, we build a product for data scientists and ML engineers who want to build their own customizable ML monitoring solution. I've been involved with machine learning and DevOps for many years, and I saw a lot of people struggling with setting up their ML infrastructure, and that's how I started this workshop. So, okay. So since I only have 30 minutes today, I'm not going to do the full live coding session, but rather a quick overview of what we built. So the full live coding session is available on YouTube. It's around 2 hours. If you prefer reading instead of watching, there's also the tutorial in our blog. So all the links are right here in the screen. I can later on send them in the Discord channel as well. And if you just want to dive deep into the code, everything is available on GitHub. And I'm going to send the links to all of those in Discord. Okay, so here's the story. So when you have 1 or 2 data scientists in your organization and they start working on new projects, you probably focus less on your ML infrastructure, right? But when you have more data scientists or when you start deploying models to production, then the need for proper ML infrastructures becomes crucial. And since every organization is unique, there are different needs for infrastructure across the ML pipeline. And here you can see some common one. You have data collection and versioning, right? You have this. Maybe you need a feature store. You probably need a way to manage your experiments and how to package and deploy models, how to then push them to production and serve them, and how to monitor them. So maybe some of these problems are relevant to you. Maybe some of these problems are completely irrelevant to you. And maybe you have other problems that are relevant to you but are not written here. So I believe that there isn't a single way to build your ML infrastructure. And before even starting, you need to deeply think and understand your needs, your problems, prioritize, and find the best solution for each problem. Okay, so what in the workshop? So we focused on the following problems, the ones marked as green. So we use DVC for data versioning. DVC is an open source tool for data versioning. MLFlow for experiment management and packaging. So MLFlow basically tracks all of your experiments, all of your machine learning experiments, and send them and basically stores them in a centralized place. Then we built fast API-based model servers and show how to monitor them for concept drift and performance degradation using Aporia. So all of that was on top of AWS, but in theory, you could also use Azure, Google Cloud, or any other cloud provider. Actually, since starting this workshop, I've actually seen people who do this on-premise, which is pretty cool. It's important to know that when building your own ML platform, you shouldn't take any of those tools for granted, even Aporia, but you should evaluate the alternatives. Some of them are written here because maybe they are more appropriate for your use case. Okay, so before jumping into the architecture and code, let me make sure we are aligned on the basic technologies that we are going to use. So let's talk about Kubernetes. And I like to explain Kubernetes in the following way. Let's say that you have a traditional operating system like Linux, Windows, Mac OS, Android, iOS. Usually the traditional OS is installed in a single machine, right? A single computer, and it allows you to run multiple applications on top of it. So in a simplified way, Kubernetes is similar to an operating system, but it can run on multiple machines, not just on one machine. So a traditional operating system can run on a single machine and let you run multiple applications on top of it. And Kubernetes runs on multiple machines and let you run applications on top of all of them. So for example, if one of these applications is a model server, a model that serves predictions, and suddenly you get a lot of predictions, then if it was on on a traditional operating system, it might crash because it doesn't have enough memory. But with Kubernetes, you can just keep adding more machines, therefore more resources, and make replicas of the application, make it run multiple times, and this way you can very easily scale and make your system much more reliable. When you install an application on Ubuntu, for example, you run apt-get install. I'm sure all of you know this. When you install application on an Android phone, you can go to the Play Store, and Kubernetes has multiple methods to install applications. But I think the most popular one is Helm, which I used extensively in the workshop. So for example, you can do Helm install MLFlow to install MLFlow. Just as a reminder, MLFlow is the experiments management tool, open source tool that I talked about before. So it's important to note that Kubernetes is not really an alternative to a traditional operating system. The Kubernetes agent actually runs on top of Linux usually, but at least to me it helps understanding it. Yeah, and most of it is based on Docker containers. So so in the workshop, I use the following AWS services. Again, this is just a basic alignment, so we're all on the same page. So we have S3. S3 is basically a file storage service, and each S3 instance is called a bucket. So in a bucket, you can have files and folders just like a disk on a normal machine. So in the workshop, we have an S3 bucket for the models, an S3 bucket for the data, etc. ECR is the Docker container registry, so it allows you to push and pull Docker images from it. So in our case, we are going to have a Docker image for each model and push it to ECR. EKS is managed Kubernetes. So basically, AWS take care of a lot of details behind the scenes and just make it pretty easy to use Kubernetes. So that's EKS. And finally, we have RDS. So RDS is a managed database. And specifically, we're going to use Postgres. Postgres SQL, it's an extremely popular SQL database. Okay, so let's talk about the architecture. So we are starting from here, from this point, and let's say that we have a data scientist who wants to start a new project, a new model. We are going to build a template for him, so he can easily clone the template and start working on the model from there. So this template will include a very simple model, and that model will be the starting point for the data scientist. So we're going to use a tool, an open source tool called Cookiecutter for templating, and in the workshop, I actually show how it works. So the data scientist can then start training and experimenting, and each experiment is going to be sent to MLFlow, so training and experimentation, and then each experiment goes to MLFlow. Okay, so MLFlow is an experiment management system. It's going to run on top of Kubernetes. And that means, of course, that we'll need to spin up this Kubernetes as well. And we're going to use EKS for that. Okay, EKS, it's the managed Kubernetes service in AWS. Terms can be a bit confusing, but it makes sense in the end. So yeah, so MLFlow is going to save the model file themselves. Okay, they're usually pickle files like for XGBoost or IGBM models, but it doesn't matter. It can support any type of model. So we send models to MLFlow, and then those models are going to be stored in this artifact storage. Okay, so this artifact storage is an S3 bucket, basically like a hard disk in the cloud. And all of the pickle files throughout all of the history will be saved here. So this bucket will contain the model pickle, and MLFlow is also needs to use the this model metadata database. So this is a Postgres database on top of RDS. RDS, again, it's the managed database service in AWS. So we have this model metadata database. And every time we send an experiment, every time we train the model and send an experiment to MLFlow, then the pickle file is saved in this S3 bucket. And metadata about this experiment is saved in this database. So what do I mean by metadata? It could be, for example, the date. It could be some metrics. It could be any of those stuff. Okay, so that's MLflow. And additionally, so this is how we're going to track our experiments. And additionally, we're going to use DVC. So DVC is a shorthand for data version control. It's also an open source tool. And each version of our training data set is going to be stored in DVC. It's also an S3 bucket and hard disk in the cloud. So why, you might ask yourself, why is it so important to store all the history of your model and data? And I think there are many reasons for that, but one important reason is when you have an issue in production, you want to be able to see exactly what model and what data set that model was trained on. So I think that's a real best practice when you are designing your ML infrastructure. You want to have full history of your data. By the way, this is a little bit more advanced, but something that's also important is data lineage. So I can talk about it later on in the QA if you'd like. So this is the dev part, okay? This is the model development part. Now let's look at the production part. So we are going to run our model servers. Those are model servers on top of Kubernetes. So in this example, we have 3 model servers, and these servers are going to load the model that they serve from MLFlow. Okay, so this model server talks to MLFlow, and it loads the pickle file from the S3 bucket, okay, where the model is stored. Okay, so on the Kubernetes, we're going to have MLFlow and the model servers, but one problem, or I guess it's not really a problem, but one thing that you need to take care of when you install an application on Kubernetes is that this application isn't exposed to the internet automatically. Okay, most applications are internal and you cannot access them from outside. So since we would like to call those model servers externally, we need to expose them. And the way we're going to do that is using Terrific. So Terrific is an API gateway, and it's going to help us expose those applications to the internet, or not necessarily the internet. It could be an external server or something like that. So let's say we have a web application that wants to make a prediction. Okay, so this web application will need to create an HTTP request. It's going to, specifically in the workshop, it's going to be an HTTP post request. Okay, to /my model, the model identifier /predict. And in the request body, it's going to have the parameters, the features of the model before pre-processing. This is going to Terrific. Terrific knows that since the URL starts with /my_model, then the correct model server in this case is, for example, model 2. And then model 2 will make the prediction and return the response, the prediction to the web application. Okay, so that's the general architecture of the tiny ML platform that we are building. Okay, so let's talk a little bit about infrastructure. So usually when you set up infrastructure in the cloud, in AWS, it looks like this. It's really complicated. You have a lot of parameters and there's a lot of room to make mistakes. So just one funny story that I can tell you here is that just when we got started, I made a mistake when I think I created a database, and I think in the provisioned IOPS, I think I put it like something like free, like another extra zero here, and then the cost was like 100 more or something like that. That's crazy. I just simple mistakes can cost a lot of money. So just this is one thing to note. So instead of doing this, instead of defining our infrastructure in the UI, we are going to use a concept called infrastructure as code. So specifically, we are going to use Pulumi. Now, there's an alternative tool for infrastructure as code, which is a little bit more popular. It's called Terraform. But essentially, they are the same thing. So what's infrastructure as code? So instead of defining our infrastructure in the UI, in the complicated UI that I showed before, we are going to define the infrastructure in code. Okay, so in this case, this is TypeScript code. It's a type JavaScript. So in this case, in one line, we basically define a Kubernetes cluster on top of EKS. EKS is the managed Kubernetes in AWS. And we define an S3 bucket. Okay, so in the code, we define resources. Now, it's not actually going, running this code. So I can run this code using Pulumi app. So I have this file, and then I run Pulumi app, this code file, and then run Pulumi app. And then Pulumi makes sure to spin up those resources in the cloud. Okay, so if I write here that I want an EKS cluster, then Pulumi makes sure to create this EKS cluster in AWS. Okay, I hope this makes sense. And one thing to note here is that if, for example, I comment this out, for example, let's say that I already run this, and then I already run this code and the resources were curated, and then I comment this S3 bucket because I decided that I don't want it anymore, then Pulumi will know to make the diff. Like it knows what's currently in the cloud. It knows what I want to have in the code, and then it makes sure to remove that S3 bucket, but not touch this EKS cluster. Okay, so it makes a diff like git diff, just not git. It makes a diff between my code, my desired infrastructure configuration, to what I actually have in the cloud. So so we talked about the concept of infrastructure as code, but what are the advantages of that? So first of all, each change to the infrastructure can be code reviewed. Okay, so you are much less prone to mistakes. So each change in the infrastructure is not going to the UI and changing something. It's more like making a pull request in GitHub. Okay, so that's much safer way to do this. A second advantage is that you can easily share infrastructure components. If I build some cool component using EKS and a database and stuff like that, I can just send my friend the source code for this component, and then he immediately have that. So I believe that this is very strong, specifically for the MLOps world, because you just have so many tools, but this technique allows you to quickly iterate and play with different tools. So I think those are like the main concepts of the workshop, of how basically the architecture and how we build the workshop. So now I'm going to show a little bit of the code, and feel free to ask questions on the way. And just as a reminder, let me go back to this slide here. So if you want to follow the full live coding session, it's around 2 hours, and it's available on YouTube. So this is like a full live coding session from scratch. The GitHub repo is available here. And if you prefer reading, a tutorial, then I'll also publish this as a blog post in this URL. Okay, so let me show you a little bit about the code. So okay, so the code is divided into two projects. The first project is called Infra, and the second project is called Model Template. So just can you please verify that you can see the GitHub, please?
Yes, we can see the GitHub.
Okay, thank you. I just wasn't sure. Okay, so yeah, so basically the code is split into two projects. Infra is the shared infrastructure for the ML platform. Okay, so you know, if I'm going back to the architecture, so most of the things here are common, you know, to all of the models. So we have the Kubernetes and we have those artifact storage, right? It's not as specific to a model. And the model template is the Cookiecutter template that we talked before that data scientists can clone and start with to build their models. Okay, so the infra contains EKS, it contains the traffic, it contains the artifact storage, the model metadata database, etc. And the model template is the template that, you know, data scientists can clone. So let me show you how it looks like. I'm going to go to infra and I'm going to go to index.typescript. And the first thing here is to create a Kubernetes cluster. Okay, so one thing that's very repeated in the workshop is okay, how did I know how to write this code, right? And with Pulumi, it's really simple. You can just do something like Pulumi Kubernetes EKS, okay, and then you can just pretty much click on the first link, and then you just copy paste that. Yeah, it's really that simple, and that's what's cool about it. So when I wanted to, for example, to create this Postgres database, this is the database that's used for MLFlow, the model metadata database, this one. So basically in the workshop, I just Google like Pulumi, RDS, Postgres, and then I just copy paste the code and just, you know, made sure that it's what I need. So that's pretty cool. So we create a Kubernetes cluster, we install Terrific. Terrific is the API gateway. So as a reminder, it's this part. Okay, so it knows which URL I am requesting, and then it knows to redirect to the correct model server. So installing Terrific using Helm, by the way. Helm is the package manager for Kubernetes. Here we are basically creating the model metadata database. Okay, so this is the MLFlow database, and this is the S3 bucket for MLFlow. It's this one. Okay, this is where we store all of the model pkls themselves. And here we install MLFlow. Again, we do this with Helm chart. And yeah, basically that's the concept. It's you know, just taking each part in this infrastructure right here and then implementing it using Pulumi. Now, one thing that's interesting is that, well, we talked. If I'm going back to this slide right here, so I talked about using Pulumi for, you know, cloud resources like S3 buckets, Kubernetes, databases, stuff like that. But in the workshop, and I think this is a pretty good practice, I also use infrastructure as code to define what runs in Kubernetes. Okay, so instead of running, so if you're familiar with Helm, then you would install Terrific by running on your command line Helm install Terrific, like an active command that you need to do. But instead of that, I think it's a really good practice to define those resources in your code. Okay, so this way, what you run on top of Kubernetes can also code reviewed and shared with colleagues. So that's pretty cool. And okay, so that's basically the infrastructure part, the common infrastructure. And I wanted to show you also, so this is this directory. And I wanted to show you the model template itself as well. So this is the template that data scientists can clone. And it's pretty simple to clone. You can just like Cookiecutter and the URL of this directory. So with Cookiecutter is a way to create code templates. It's pretty convenient. So I have some defaults here. So the data scientist can just enter the name of his model or her model. Like they can write fraud detection, and then they're going to have like a fraud detection directory with everything they need to get started. So one pretty cool tool that we used in the workshop is called Poetry. So Poetry. Oh, so every time I fall into this stack, it's Poetry Python. It's basically a really convenient way to manage packages and dependencies in Python. So instead of having different Python versions and requirements.txt and stuff like that, Poetry makes it really easy. So you can see all of the dependencies of the model right here. So this is also a pretty cool tool that I use. And the code is split into serving and training. This is actually pretty simple, pretty straightforward. Serving looks like this. It's basically a fast API server that can call model.predict and return the results. Pretty simple. And the training code is well, it's a live GBM model, but you can have any model that you want here. The only special thing about it is that it uses MLFlow. Okay, so it uses MLFlow to track everything to make sure that you have all of your history. Awesome. So another thing that we have here is a GitHub action that basically pushes the model to Kubernetes every time that you commit to master. So the usual workflows, okay, make your dev in a separate branch in a pull request. When you're done, make a pull request, merge that or squash that to master, and then this is going to build a Docker image and push that to Kubernetes. So everything is done through a make file. So you can also run everything locally. So install dependencies, train the model, pull the data from DVC, and deploy. So Pulumi is actually, I forgot to mention that, but Pulumi is used both in the model template for the model specific infrastructure and the general infrastructure. Awesome. So I think I have 1 minute left. So thank you very much. Again, all of the links, let me show that. All of the live coding session YouTube video is available here. The code is in GitHub, and we also have the tutorial right here. Thank you very much.